All right, guys, we're going to start Unit 2 here, Section 1. Now, I'm going to talk about a lot of different people. The problem I have is you could talk about these people for a really long time because they did a lot of different stuff. All right, and so we gotta take it easy. So first, we got Democritus versus Aristotle. These two guys are Greek. They were debating like what things were made of. All right, so Democritus said, well, everything's made of this stuff, atomos, which means indivisible. So this is where we get the term atom from. He said his whole notion was if you take a rock and break it and then break it into a smaller piece and smaller piece and smaller piece, you get to a point where you can't divide it anymore. So atomos, indivisible. All right. And he said the properties of everything, so properties were due to shape. So he said, like, we were talking about shapes. That's what imbues everything with different properties. Aristotle, a lot of people know Aristotle's name. Like, he dominated thought for a really long time. So, I mean, not to take anything away from him. Math, writing, philosophy, all that stuff. He did a lot. But he had one thing that was problematic. If you've ever wondered where the four elements come from, like fire, water, earth, and air, that was his idea. He thought you could combine them in different manners and figure out, get different properties. So that's what we have. This is our starting. This is BC, long time. So this, because Aristotle said it, a lot of people believed him. And then through the work of countless individuals, we get to John Dalton. We're like in the 1600s now. So this took a long time for us to get to this point. All right. And John Dalton had what he called the atomic theory. All right. And John Dalton's atomic theory, you can read right here. Elements are composed of small particles called atoms. Atoms of a given element have the same size, mass, and chemical properties. Compounds are made of atoms of different elements. And a reaction is looks like I got to change that. There we are. Is the rearrangement of atoms. So they're neither created nor destroyed. And so Dalton put this together and he goes, all right, constant composition. All right. What that means is you always have the same ratio. So water, atoms in same ratio for compounds. Because I'm running out of room here, I'm going to do compounds. All right. So like for water, it's always 2 hydrogens, 1 oxygen. It's for water all the time. That's what it is. Now, for multiple proportions, he said atoms could combine in different ratios, but then you have different things. And so our thing here is like for H2O, that's water. Anytime you run into water, you have 2 hydrogens and 1 oxygen. However, you can make hydrogen peroxide, that's H2O2. All right. Now, these are two different things. So whenever you have water, you have this, constant composition. Whenever you have hydrogen peroxide, you have this, constant composition. But what he was saying is that these elements, hydrogen and oxygen, can combine in different ratios, which they have. All right. And then the law of conservation of mass, we have atoms neither created nor destroyed. Either created or destroyed. So that's what we have here with this. Now, if you remember up here, Democritus said your properties are shaped. Now, John Dalton was like, I don't know, like what gives them their properties. So he started off good there, but his idea for like how the atom worked is he said, well, if we have all these atoms, they're like just spheres floating around in space. All right. Now, one of the problems, he openly said this, he goes, I don't know how to explain how they stick together though. So we're going to leave it at that. He did do a lot of good things. So we have this like billiard ball model, constant composition, multiple proportions, and conservation of mass.